Hello, this is Andrea Hendricks. I want to show you how you can graph other trigonometric functions. We're going to begin by graphing y is equal to tangent of x and y is equal to cotangent of x and look at their transformations, and then we'll take a look at cosecant x and secant x and their transformations. So let's begin by looking at the basic graphs of tangent and cotangent. So remember that tangent is defined to be sine x over cosine x. So whenever we have a fraction like this, we need to think about values that make the denominator 0, because that's where the graph will be undefined, and that is where we're going to have vertical asymptotes. So it's undefined, we know, when cosine x is equal to 0. And if you recall, cosine x is 0 at pi over 2, 3 pi over 2, 5 pi over 2, basically odd multiples of pi over 2. The way that we can write that concisely is just x is equal to pi over 2 plus n pi, where n is an integer. And then we know also that we have zeros when the numerator of a fraction is 0. So we have zeros when sine x is equal to 0. Therefore, the zeros of tangent occur at 0, pi, 2 pi, and a way we can write this is just n pi, where n is an integer. And so let's look at what we have on the graph. So we first want to place our vertical asymptotes, that is where the graph is undefined. So we can do that at multiples of pi over 2, odd multiples of pi over 2. Oops. Let me straighten that one up. There we go. Okay. And then the other thing we know is that we have zeros where? At 0, pi, 2 pi, negative pi, negative 2 pi. Okay, then you might want to think about some other points that are in the graph of tangent, or on the graph of tangent. Do you remember sine and cosine of pi over 4 are both the square root of 2 over 2? So we know that tangent of pi over 4 is going to be 1. So tangent of pi over 4, which is between 0 and pi over 2, is 1. Let's say that every 2 units is a 1. Tangent of 1 pi over 4, 2 pi over 4, 3 pi over 4 would be what? Yeah, 3 pi over 4 is in the second quadrant, so that's going to make that negative 1. 4 pi over 4, 5 pi over 4 is going to be positive 1. 6 pi over 4, 7 pi over 4, 8 pi over 4, and then 9 pi over 4. So we see that we have a repetition, but this time it's between the asymptotes. The asymptotes are only pi units long, so the period of tangent is actually going to be pi. Now you could get more points here, but the way that the basic shape is going to look, okay. And you can plug this into your calculator. Make sure that you're in degree mode when you do. Radian mode when you do. And you will get the graph that you need. Okay. So that is the basic shape of tangent, knowing that you need to have zeros in between the asymptotes at odd multiples of pi over 2. Now to look at the graph of cotangent, which is cosine over sine, cotangent is undefined now when sine is 0, and so that's going to be at 0, pi, 2 pi, basically all multiples of pi. The zeros come from where cosine x is equal to 0, and that's going to be at pi over 2, 3 pi over 2, and so on. So we're talking about odd multiples of pi over 2. So graphing this now, we can place our asymptotes at 0, pi, 2 pi, and then also in the negative direction. Okay. And our zeros are in between these. Okay. Now let's think about cotangent. We know that cotangent of pi over 4 would be square root of 2 over 2 over square root of 2 over 2, so it would be 1. So the cotangent of pi over 4 is 1. So it's going to look almost the same as tangent, except it looks like the reciprocal of that and the reflection of it. And I apologize, my graph is not any better. So you could continue by placing important points on the graph. Really, the key things are the asymptotes, the zeros, and then I think it makes it easier if you can remember where cotangent is 1 and negative 1, and that'll tell you the general shape of the graph. Okay? So the things that we know, the period of tangent and cotangent are both pi. If we want to graph y is equal to a times tangent of bx plus c, that is some transformation, we need to find the asymptote. So that you can do that by setting the inner expression equal to where the two consecutive asymptotes lie. So at negative pi over 2 and pi over 2. And then between those two asymptotes we have a 0. And we can do a similar thing for cotangent, except we would set their expression equal to 0 and pi. And the period is going to be pi over b, but you'll see that as we go through. So let me look at an example. Y is equal to 2 times tangent of pi x over 4. Now that 2 kind of has the same effect that we talked about before. It does a vertical stretching. I should say the range of tangent and cotangent are all real numbers. The domain is restricted by taking out those values where we have vertical asymptotes. So the period here is pi over b, which in this case our b is pi over 4, so we would have pi over 4. So when we multiply by the reciprocal, we would get that our period is 4. Now we can set pi x over 4 equal to negative pi over 2 and pi over 2, and that's going to tell us where two consecutive asymptotes lie. So if we solve this equation for x, notice we can divide both sides by pi, and that would give us x over 4 is equal to negative 1/2. If we multiply both sides by 4, x would be equal to negative 2. In a similar fashion, we can divide both sides by pi on the other equation to get x over 4 is equal to 1/2. Multiplying by 4 gives us x is equal to 2. So we have, let me mark up our graph first of all. Let's say this is negative 1, negative 2, 1, and 2. So we know we have asymptotes at negative 2, and 2. And in between those asymptotes we have a 0. And then halfway between there it reaches a value of 1 and negative 1. So think about the way the tangent does, and if you need to go back and look at that, tangent starts below and goes up, So at -1 we're going to have -1, and at 1 we'll have +1. Oops. And so the graph would look like this. Oops. And you could complete another cycle. If you go out to 4 units, you would have another asymptote. I'm sorry, if you go out to 6, because the period is 4, so if you go out to 6, you would have another vertical asymptote, and then the graph would look in a similar fashion. Okay. So if you have any questions about these, don't spend so much time. In fact, in your book you only have a few problems that you need to do. So you can use your calculator to check this. The main thing I want you to be able to do are to find where the asymptotes are, find where the zeros are, know how to find the period, and get the basic graph. Okay, so contact me if you have any questions. Thanks.